So yesterday, last day, Friday, we went through all of these guys up there, right?
Yes.
And we learnt, where are they? There they are. And we learnt that they have names that go with these chains. And we drew them all, and we had lots of fun doing that. And I'd like to A, review, remind, rememorize some things, and then B, do a little bit extra about the basics. So, without looking at that thing I just scrolled to, but rather just sort of looking somewhere else, like the board. What's one carbon called? So we have one carbon. Methane. So carbon 1, hydrogen's 4 is called methane. What if we have two carbons? Nope. Ethane. H6, 3 carbons. Propane. 4 carbons. Butane. Now, once upon a time ago, a student said to me that this is how he memorizes it, and ever since then, it caught like wildfire in that class, and so ever since then I tell all my students that perhaps this is a good way to memorize these first 4. Monkeys eat peanut butter. Sounds dumb, sounds funny, but it's perfect. That's right. So monkeys eat peanut butter. And then the rest of them are like the math. So you don't have to memorize them, they're just like the math symbols. So C5, H12 is, 5-sided shape is pent. I've gone, so this is pentane. C6, hex. The muttering can stop, the answering of my questions can continue. C7, H16, heptane. C8, H20. That doesn't sound right. H18. What's C8? Octane. C9, non-ane. And C10, decane. Okay, they all ended anes. Did you notice that? Ane, 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 ane. Because what we're doing, I'll just remind you once today, only one reminder. You're in school, not the locker room, not the weekend. Good. It's the only warning you get today. They all end in ane, because these are all called alkanes. Okay? Now this is the bit that we didn't really talk about last week. So we're going to learn about alkanes, which we've already started, and we're going to learn about alkenes by the middle of the week, which we haven't yet. So the name alkene changes. So guess what? The ends of these are also going to change. So if it's an alkene with 5 carbons, you're going to name it pentene instead of pentane or alkane. Get it? Okay. So an alkane's general formula is CnH. You guys were already kind of getting the pattern before. You were going 4, 6, 8, 10. Pick up your pen and start writing this down. N plus 2. Okay? So when it's C9, it must be H. 2 times 9 is 18. Plus 2 is 20. So it must be C9H20. And C10H22. And so C100H 202. And those things tell you it's an alkane. Spencer, you need to start writing.
I wrote it.
You've written C100H202. You've written the general formula of CnH2n plus 2.
I just didn't write that.
Okay, so write an example. pulling teeth sometimes. Okay, so the other thing about alkanes is that they are carbon-carbon single bonds only. So in your bonding unit, you had a double bond between carbons sometimes, right? Do you remember that? And they won't have been alkanes. They would have been an alkene if it was a double bond. So all of these have single carbon-carbon bonds. And because of that, we call them saturated hydrocarbons. What was our definition for saturated in solutions, in the solutions unit? So a saturated solution, what is that? Josh? Filled up. Wait, pardon? You can't dissolve any more solute into the solvent. Okay? And because of that, because you can't get any more solute to go into the solvent, your concentration is as high as it'll be. You can't get it to be any more concentrated. Alright? So this is kind of the same idea, where you think I have as much hydrogen on there as I can get on there, but you don't use that as a definition. The definition for saturated is all carbon-carbon single bonds. No double bonds, no triple bonds. Okay? And a hydrocarbon contains what? Hydrogen and carbon only. Okay, so as soon as there's a Br, or as soon as there's an oxygen on there, it's no longer a hydrocarbon. So it contains only hydrogen and carbon, saturated in single bonds only, saturated hydrocarbon. So now if I ask you what's the definition of saturated, you have to think, is it a solution that they're talking about, or is it a hydrocarbon that they're talking about? As to whether I define it with carbon-carbon single bonds or maximum amount of solute into the solvent. Okay? But sort of in its essence, it means you've got as much stuff in there as you can, in its essence. But don't ever define it like that. But you're right. Okay, everybody get that? So these were all straight chain molecules that we did. They were all one nice little line. But I told you they don't all have nice little lines. They sometimes have branches off of them. So today we're learning about how to name the branched ones, not just these straight chain ones. You memorize 1 to 10, you're done. Okay? So that brings us into this category over here, this sheet. Okay. So the first thing I'd like us to note is that these have hydrogens on them, right? I was just being lazy and I didn't draw them. Got it? So, how many hydrogens are in this first carbon? 3. Well, and this carbon here? 1. Good, because only 4 sticks on the carbon. And how many on this carbon?
3.
And this one?
2.
And this one?
2.
And this one?
3.
Very good. Have the rest of you written it down?
Yes.
No. On the next page are the steps for doing this. Okay, so don't worry, they're there. You don't have to write them down, but I'll just talk about them. Okay? The first step that we do is, and this is like the proper teaching way, you say the longest continuous chain of carbons. Okay, that's just a fancy way of saying find the longest line of carbons connected to the next carbon connected to the next carbon. Okay, so in that case, it's here. Here is the longest continuous chain. So this is called a chain. And what we do is we put a box around our chain, and then this here is our branch. So like a branch off of a tree. It's not part of the main trunk, it sticks off to the side. Okay? And the analogy I like to use is that the chain is like a bracelet chain. And the branches are like the charms that dangle off of this bracelet. Okay, so the bracelet itself is 1, 2, 3, 4, 5 carbons long. And so we call it a pentane bracelet. Okay? The branch is 1 carbon. What did we call 1 carbon? Yes, on Friday? Methane. So I'm still going to keep the meth bit. But because it's a branch and not the chain, I'm going to change the ending from methane to methyl. So as soon as you see this YL, you know it's a charm on the bracelet, not part of the bracelet itself. So methyl. Everybody okay? And then the next question you have to ask, if this is a bracelet with charms off of it, is which link is that charm clipped to? Is it clipped to the end? Is it clipped in the middle? Exactly in the middle? Right? No, it's clipped onto link number 2. And so here's link number 2. 2-methyl-pentane. Everybody get the bracelet and the charm. Okay, so this is how you change it to sound to like be the proper speaking terms. Number 1, you find your longest continuous carbon chain. Number 2, you identify your branches. Number 3, you number your chain from left to right, 1, 2, 3, 4, 5, or from right to left, 1, 2, 3, 4, 5. And I have a look at which number is the lowest. So who wins here, the red or the green? And red is the lowest number, so it wins. 2 wins, not 4. So this becomes 2-methyl-pentane. Everybody okay with that? In fact, actually, 1, 2, 3, 4, 5 methyl. Here's your longest continuous chain, pentane. Here's your branch, methyl. We would number it left to right or right to left, whatever's in the lowest. So in this case, I go 1, 2. So it'd still be 2-methyl-pentane. So these guys have the same name. They must be the exact same molecule. In fact, if I were to take this one and pop it off the board and show it to you, where does the methyl go? Watch, here's the methyl, this marker. Pop it off the board, turn it around. It's exactly the same as this guy. See that? It's the same molecule, has the same name. It's just that we're representing a 3-dimensional thing that turns and rotates on a paper. So there's many ways of drawing it. If you were to draw it like these, the models that you've done that are hanging to the ceiling, they would look exactly the same. If you were to actually stick it together 3-dimensionally, they would look the same. So this one has the same name too, right? So it must be the same molecule as well. Where's your longest continuous chain then? Oh, so instead of laying out my bracelet beautifully straight on the table, I've sort of chucked it onto the table and it's turned around a bit. See that? And the charm is there. It's the same bracelet, only instead of laying it out flat on the dresser, it's got a turn to it. Find your longest continuous carbon chain. 1, 2, 3, or 1, 2, 3, 4, 5. 5 is longer, so we pick the 5. Yes, Spencer.
Why does it start at the top left C? Why isn't it just like the 4 carbons?
Because if it was just the 4 carbons, 1, 2, 3, 4, it is a longer chain than the 3, but it's not the longest. I could still go 1, 2, 3, 4.
So it doesn't matter what side you break.
No, I could go, but as long as you turn the corner. Because that is the same thing as that. Yes?
What if you turn up the first one? Would that still be correct?
Yes, if I went like this,
Yeah.
yes, and I would still end up with pentane, 1, 2, 3, 4, 5, and I'd still end up with methyl, there's my methyl, and I'd still end up with 2 methyl, 1, 2 methyl. So if the person beside you has drawn a box turning a different way, that's okay. It just means that if I put it on the table with a bend going this way, well look, I'm looking at that bend going left, but you guys are all looking at that bend going right. And mine looks like a number 7, yours looks like a L. It's still the same line, still the same situation, it's just that you're looking at it from another angle. Okay, so that's fast, and yours is just from a different angle, a different viewpoint. Any other questions on 1 and 2? Okay, so number 3. Your longest continuous chain is again a straight line, so that's lovely. 1, 2, 3, 4, 5, 6, 7, 6. And so I put a box around my longest continuous chain. And then I put a circle around my branches. In fact, I like doing them in another color when I'm teaching, so. Okay. Now, the chain itself is 1, 2, 3, 4, 5, 6 long. Okay? So it's called hexane because it's 6 long. The charms I have stuck on it are how many carbons long on the charm? 2. What was 2 carbons again? F. No, F. Yesterday's work. Yesterday's work, how many was 2 carbons? Fa, right? Monkeys eat peanut butter. Fa. So it's F. But these are charms. So we don't call them F-ane, we call them F-O. So here's an ethyl, and here's an ethyl. How many ethyls do I have? 2. So I have 2 ethyls. I have 2 charms that are 2 carbons long. And what carbon are they on? What length are they on? 1, 2, 3, 4. 3, 4. You should be annotating. Okay? Yes?
But it still works if you go up or down on one, right?
Yeah. Not down. Oh, yeah, down.
Wouldn't it be longer if you went down and then all the way down the back?
Nope. So which way do you want to go? You want to go down?
Yeah, and then,
And then,
oh, okay.
and then what? Up?
No, I was confused.
That'd still be called 3,4-diethylhexane. 1, 2, 3, 4, 5, 6. So still hexane. Off of carbon 3, I have an ethyl. Off of carbon 4, I have an ethyl. Still called 3,4-diethylhexane.
Do they all work out like that?
As long as you've found the longest chain. Yes. If you've got hexane and your friend's got hexane, you're probably okay. If you've got hexane and your friend's got octane, ooh, they have found a longer branch that you missed. Okay? Or perhaps they've not found the right branch and you're still right. But okay, number 7, or 4, I mean. Longest continuous chain. Heptane. I've got a methyl and an ethyl. Can you see why we choose to number this right to left and not left to right? Smaller numbers.
Smaller number.
So my block numbers there, 1, 2, 3, 4. Or I could have numbered it 1, 2, 3, 4, 5, 6, 7. But then my numbers would be 4 and 6 in my naming. Those are higher than 4 and 2. So I'm choosing to number it right to left. So I get lower numbers. Once you've picked a direction, you stick to that direction. Yes?
Would that also be wrong if you meant left to right?
Yes, it would be wrong. Yeah. Okay. And, oh yes, and then, so this is on carbon 4, this is on carbon 2, and I'm going to write the names alphabetically. So ethyl gets written down first before methyl, because E comes before M in the alphabet. So, 4-ethyl, because of the alphabet, 2-methyl heptane. Oh, and by the way, this is always one word. See that? There's never a space there. Ethyl heptane, one word. Methyl heptane, one word. Okay? Questions? Ronan?
There's still hydrogens around the album, right?
Yes, yes, yes.
Okay. But they just don't matter really when
They do matter. Were you here Friday?
Yeah.
So they do matter, but we just get lazy and don't draw them sometimes.
Oh yeah.
But if we're doing, and if I draw, the problem as a teacher, if I were to draw hydrogens on all of these, you get so, like, it becomes such a busy diagram that you can't see the carbon chain nicely. Does that make sense? However, if I was handing this in to you, or like doing proper notes for you, not just some sporadic examples to teach you, I would put in every single hydrogen.
On a test, would you put the hydrogens?
On your test, you must put your hydrogens.
On like the third question, why is it like the numbers are in front and then the fourth one, they're in front of each one instead of just in front of the whole thing?
Why? On number 3?
Yeah, like the 3 and the 4 are in front of the whole thing, and then
Oh.
the next one.
Because the 2 goes with the methyl, the 4 goes with the ethyl. Here, the 3 and 4 go with the ethyl. There aren't 2 different things. I suppose somebody could have said we should name this 3-ethyl 4-ethyl hexane. Fair play, but we don't. The problem, oh, go ahead, Nick.
So on that number 4, if the one coming off of the branch coming off of the 2 had 2, it'd be like the same as the other one.
If this had 2, yeah, then it'd be 2,4-diethyl. Yeah. So this is called the IUPAC naming system. I can't remember what it stands for. International something or other, something or other, something or other. And it's because, you know, before this, we all had common names. Sugar, glucose, fructose, vinegar, acetic acid even. And, you know, it's not called vinegar in France. So how do the French scientists know what I'm talking about? So they had to have like a normal, like, look, everybody, we're going to follow these rules.